Okay, let's get started with our next lecture here in decisions. Decisions allow us to make choices throughout our program. So why would we need this? Well, say for instance, we're playing a game, and this game has a choice that's put in front of you. Depending on which choice you choose, a different outcome will happen. You have a different set of programming for each one of those cases. It's very important for us to be able to represent that in code. Let's consider this real quick. We've written this as an assignment a few assignments ago, and it was somewhat formatted in a was you went to a restaurant, you had a meal charge, and after that came the tax and the tip. Now the tip was a constant that was just already predetermined, ready to go. You have no choice and no say in the matter, and that's not really how things are done. So what if we allowed just, we're getting more towards an ideal model here of what a receipt should be, and we give the user now a choice, right? We give them a choice of either 15, 18, or 20% tip. Okay? Perhaps we even added in 0 if they don't want a tip. So we have all these choices. How can we represent these choices in code? So again, if the user chooses between these rates, if. And that's just it right there. We'll find that in C++ and in other programming languages as well, it's not just restricted to C++, that we see that a lot of the way that we speak naturally and natively very close to how things are done in the language. And again, it's because the language is a high-level language. It's meant for humans to interface with easily. It's very hard to speak the machine-level language fluently and very easily. So that's why these high-level languages were created, so that we can easily programs are being resolved into that long string of ones and zeros that a lot of people do not understand, that very binary level of machine language here. So that's what's going on with this this sort of flow going forward. So back to this here, this if. The if is actually the keyword that we're looking for. And that brings us to the if statement. So anytime that we have a decision to be made inside of C++, we can use this decision structure, the if statement. So how it works is you use the keyword if, and then you can present a decision, a condition. And if that condition is met, it's either true or false, a certain decision can be made to go to one block of code or the other. Now, with the if statement, if the condition is true, it can run into some extra conditional. Skip over that conditional code and just go to whatever's next in line. And that's how that works. So let's look at the anatomy of this real quick. And it should be noted that the if statement is the most simple way of doing selection in your code. There are other ways. We'll learn those, in time. So that's kind of, what we're starting out with. So really quickly, let's look at this. We have a keyword if, and then we have in parentheses a Boolean test expression. Okay, so there's something wrapped within these parentheses that's there. And then we have curly braces. And then we have statements that are inside of this. Let's break this down real quick. So keyword that signals that's a decision. The parentheses wrap and say, hey, this is the condition, the stuff in between these parentheses. And that's a Boolean test expression. No matter what you put inside of here, it must resolve to a true or a false. The curly braces here are meant to contain multiple, so this is the body of the function. Okay? So the first line of the if statement is called the header, and that's this here, the if keyword and the condition. It consists of the keyword if followed by the open and close parentheses. Within the parentheses, you'll see the relational operators. So the relational operators are something that we're going to learn in order for us to represent this in terms of true and false, we can't just use the operators that we currently know about. And those are, plus, minus, division, modulus. If we just stuck those in there, we're just making a statement and we're not asking a question. And that's what the if is all about. The if is asking a question. If this is that, or if that is this, those are the types of questions that we need to be asking. So in order to do that, we're going to learn some new operators. And once we can evaluate whether this is true or false, then we can execute or ignore what's inside of the body of this if statement. Okay, so notice this real quick. Notice that the if statement does not have a semicolon after the test expression. And you should think of this as kind of like a structure. Okay, so a very common mistake is to have this phantom semicolon that's right after the condition here, or to put it somewhere else besides at the end of each statement inside of the body of the if statement here. So make sure that you're not putting your semicolons after this line here, the if and then condition. So let's hone in on the condition a little bit more. The condition evaluates as a true or false statement and must resolve to either true or false. And we're going to take a look at these additional operators. There's a series of relational operators and logical operators, and let's take a look at those real quick. So here are the new operators. We have greater than, which is the chevron that's pointed to the right here. It's kind of arrow pointing to the right, open towards the left, and we've learned this, in our basic arithmetic growing up here. We have less than. Then we have an exclamation mark, and this is the logical not. We have the logical and these symbols are you might have always thought of these as ands. These are actually called ampersand, so that's what that symbol is called. Then you have these vertical bars, and this is actually, again, 2 characters as well, just like this, 2 characters. These vertical lines are actually located on your keyboard right above the Enter key and right below the backspace key. And the way that you access that is with the Shift key. Hold Shift key down, and it's the / key, and that will make those vertical lines. And 2 of those means the logical or. So this is and or, not, less than, greater than. Then you have the compound operators. And these are just kind of like you've seen them with the other set of operators, where if you had plus equals, minus equals, times equals, and that's the same thing as saying this and that. Okay, so this would be greater than and or equal to. So greater than or equal to. This is less than or equal to. Okay, so it's just including the logical or on this as well. I think I said and a second ago, but that's confusing. I meant logical or, so this would be this or this, this or this. Now, double equals. Now, this is why I made a big deal about the assignment operator earlier when I said don't read this as equal to. And the reason why is because I knew this was coming, and this is a very common mistake with students that are just learning this subject for the first time that may not have been programming at all. So what you want to look out for is the double equals as not the assignment operator, but equivalent to. Okay, this is equivalent to this. So don't ever think of this as the assignment operator, and vice versa. Don't think of the assignment operator as equivalent to inside of an if statement. It simply won't work. Lastly, we have another compound statement here. We have something being said that it's not equal to. Okay, so not equal to. And this simply means instead of it evaluating if it's equivalent to this, it's not equivalent to this. So if we're trying to find if something is not equivalent to that, that would be the way to invert this equivalent to here. Again, the logical not is an inversion. It simply doesn't mean change it to false. That's not what it means. We'll kind of explore this in another couple of slides coming up. So expand on the logical not, and or just a little bit more. The logical not is used to invert the evaluation or assignment. So it's an inversion. It is not meaning change it to false. Okay, so it's just whatever case we're currently evaluating, invert that. The logical and is used to evaluate multiple operands in a single condition, so the left and the right side. So it's the same as saying something like this: I will go to the movies and I will buy popcorn. So I've just told you I'm going to do two things. And if I do not do those two things, both of those two things, then I've just told you a lie, because that would end up being false. Okay? So if I go to the movies and I buy popcorn, then yay, it's true. I've held up my end of the bargain. So my statement is now true, and we can continue on. Now the logical or is one or the other. It doesn't matter. As long as I do one or the other, then that's going to resolve as true. Okay, so if I go to the movies or I buy popcorn, as long as I do one or the other, I have not told you a lie. So that's kind of what's going on here. Okay, so the conditional operators, back to the conditional operators, which is these series of operators that we've just learned, relational and logic. Check out, here's a way that we can use the greater than. So here's the greater than inside of an if statement. So we have if y is greater than x. And notice how it's naturally set up like a question. If y is greater than x, okay, so there's the question. And is y greater than x? We have x is equal to 1, or I should rather say x is assigned with 1. Y is assigned with 2. Okay, so 2, y 2 is greater than x. Yes, so this will be, and this will end up being true. Okay, because y holds the value 2, x holds the value 1. This would end up being true, which means that anything that's inside of these curly braces here will execute. And so we would see this cout statement here, y is the highest number, because this is true, and this would run as a condition. If this were false, it would simply evaluate it, decide it's false, then skip all of the conditional code, and then start right after the closing brace here, anything that's next in line. And that's how that would flow. So going back to the logical not, and or, all of these things, this is something that you might have seen in a philosophy class or a logic class that you might have taken. And if you haven't taken, I highly recommend the class. It pairs with computer science really, really well and helps you become very strong with concepts of logic. And if you've ever taken this class, then you would probably recognize this chart. If you've ever heard about a truth table, this is something that you would be very familiar with. If not, you can look up truth tables and kind of understand logic in a little bit more detailed spec. If not, don't worry, you don't need to know that just to understand this concept. I want you to think of the left side and right side of the statements inside of an if statement. Think of them as P and Q. Okay, so this is kind of like, I will go to the movies and I will buy popcorn. Okay, and then we have an operator in between those statements. Okay, so these are just statements. I will go to the movies and I will go buy popcorn. And then the and will connect those two together. So in the if statement, if I have an and in there, okay, so in the if, I have if I will go to the movies and I will buy popcorn. Okay, and I end up doing that. I say yes, I go to the movies, and yes, I go buy popcorn. Then it resolves to true. So the sum of these two, if I do both of them, and it makes that so that if I have the and as what I'm evaluating, I've done both of these. I've held up my end of the deal. This ends up being true. Now, for the and, any time that one side of the setup here is not true, this ends up being false. because the and says I will do this and that, both of them combined together. So here's what's going on if I end up don't buying popcorn. I go to the movies, but I do not buy popcorn. Therefore, this entire thing is now null and void because I said I would do this and that. So it ends up being false. And if I just don't go to the movies, but I buy popcorn, well, that doesn't count because I told you I'd do both, so that it also ends up being false. And if I just don't do anything, then I completely just flat out lied again, and that is going to resolve as false. Okay. All right, so now looking at the or. On the or side, as long as I do one or the other, one of these sides, I'm okay. So if I go to the movies or I buy popcorn, I'm okay. If I go to the movies but don't buy popcorn, I'm okay because I said I would do one or the other. And again, too, if I buy popcorn but I don't buy the movie ticket, then I'm still okay because I did one or the other, and I told you I would do one or the other. Okay, and if I just don't do anything, that's actually the only case into where I won't actually have held up my end of the bargain. Okay, so on the or side, that's the only case where this will be false, is if nothing is done. All right, so now we have the ability to branch into different directions depending on this. Now, with the if statement, we only had the ability to represent a single set of conditional code that was either going to be executed or just completely ignored. Now, with the else statement allows us to run the conditional code that's in the if statement or the conditional code that's in the else statement. So something's going to be triggered no matter what. And this kind of represents that fork in the road to where you must make a choice. You cannot go forward any longer. You have to make a choice, either left or right. And that's one of the decisions that we're going to be making in some of our assignments, is either you have to go one way or the other. There's no just skip over it and ignore it. So some conditional code will be ran no matter what. Okay. So let's look at the else statement anatomy real quick. The else statement requires an if. So if there's no if, the else will trigger an error because this is a dependent of the if statement. So once the if statement is evaluated, it has either the test condition will flag it as true, where all of the body of the if statement will run, or it will evaluate as false, and then it will skip down to the else section here. Now notice that the else does not have a Boolean test condition. There's no condition for it to evaluate. And that's just because it's either going to go to the left or to the right. Okay? So if it does not go to the left here, say we represent if as left, all right, it's going to automatically go to the right. It's going to make the other choice, because what other choice is there? Okay, so that's what the else is doing, is it's just going, okay, if we don't do this, we must be doing this. So that's why there's no condition to evaluate. It will just automatically be chosen if the original test condition ends up being false. Okay? And again, you can put curly braces on here to evaluate multiple statements in here, so you can have as many statements as you want inside of the body of these if and else statements, as long as you have them encased within inside of the braces. All right, moving on. So here's some things to just kind of look out for, some bullet points. Every else statement must have the matching if statement. Again, you can't just have a dangling else somewhere. That's weird, and it doesn't work that way. Many students struggle with keeping the braces lined up on their if and else statements, and that tends to get a little out of control when you start having multiple if and else statements running around. And we're going to take a look at that a little bit later as well. And although the braces are optional for single line statements, so some of you might already know this if you've taken a programming class before, or let me kind of key you into this here, you can actually omit the braces within inside of the if and else body statement, or the body section there. You don't have to have the curly braces there, only if you have one single line that's inside of your if or else. If you have multiple lines, you need to keep the braces in there. I do like it if you guys would use braces no matter what, just for learning purposes. It's neat, it's clean. It is a little extra, but at least you know at all times where the statements are contained and where they're not. It would just be much better to do that. So I would highly recommend that you keep those braces on even for single line statements going forward. It just will keep things nice and neat and clean for you. And you'll see a little bit later why that would be so crucial. All right, so we talked about the if, we talked about the else statement. Now, what if you have multiple choices? And when you come to a conclusion, you're done making a choice. So what if I tell you to pick rock, paper, or scissors, right? You have 3 choices that you can pick. And I ask you the question, well, you want to pick rock, paper, or scissors? And you end up saying, I want to pick paper. Okay, so I ask you the question, do you pick rock? You say no. Say, okay, do you pick paper? You say yes. And I say, okay, but do you pick scissors? No, I already picked paper. So why do I keep asking you over and over another option if you've already made your decision? And that's kind of something that's a pitfall of the way that we structure some decisions inside of code, is that we're actually still evaluating the other cases even though we've already made a decision. So the else if allows us to add a condition onto an else statement, so we can say this, okay, if not this, then it must be this, but does it match this one here instead? No. Okay, well it must be this here, but does it match this? And if it doesn't, then we can just have a default case at the very end, so we can have it, if it's not this, then it must be this, as long as it matches this, and if it's not that, let's try this. And if not, well, then automatically it's going to be this. So we can actually have these else ifs put on another condition. So that's one thing that we can take a look at. All right, so just to recap on this, using this for exclusivity, this will only execute as long as it's not found a match on this list here. So in this case here, where we have number is equal to 0 here, it's assigned with 0, and then we will pull that number in from the user. Now if I pick 2, if 2 is my number, okay, I evaluate number, no, it's not that, yep, it's this one, okay, so now I execute this body of the if statement here, the else if statement, and then I'm done. So as soon as I finish this and I come to the closing brace here, I then will stop and then skip over every other case, which puts me right here. And then the next thing is simply to return 0. So you can kind of think of this entire decision here as one decision, because the else here, remember the else, is dependent upon an if. Now the reason why the else if here, we can have multiple else cases, because I told you, there can only be one else, but these have the else if structure, and the else if structure can kind of tier into this ladder system here. So that's kind of something to look out for as well. All right, so this you may have been thinking this as well. What if I have a decision within inside of another decision? Right? This inception of decisions here. And the answer, yes, you could put if statements inside of other if statements. And that's no problem at all. That's actually a very common thing, and it's called nested statements. And that's a statement within inside of a statement. Now this can get really tricky really quick. So this is where your braces come in absolute handy, and it's an absolute must to keep these aligned perfectly. Anytime that you have an if statement, anything inside of the body of that if statement is indented once, right? It's a child of that structure. So just like in main, anything inside of main function is indented once. When we have that if statement, anything inside of the body of that structure is intended once. And I use the word structure really loosely here. It's just meant to say it's a collection of pieces of code here. There's an anatomy to it, and there's a body of that, and that body is indented once. Okay, so you can see that here. This if statement here, we have it indented once, and then that has its own series of braces here, and then that statement is indented once. So anything that's in here, it kind of starts to go out in this little horizontal here. Okay, so you can see real quick that these are all kind of wonky here. We have conditions, and we have this flow chart here. So if we make one decision and we say, okay, well, since you made that, now I can ask another question here, and that's what this is doing here. So it's saying, okay, if this is true, then I have one more other question for you. Okay, and if that's true, then I'm going to give you a statement. If that's not true, then I have an else case for that that's still within inside of the original if. So it's just two questions. There's two questions inside of this one question. And if we were to answer false for this here, there is a linked, and you can see the line drawn down to the else case down here. This is linked, this else is not actually, linked to this here, because this is a child of this body here. The body of the if statement ends, see the curly brace right here, and then the curly brace right here. The body of this ends here. So this is directly below the if statement. Okay, so this else links to this if. Just like this else here, see the end brace of the if statement here? This else links to this if statement. So you can imagine if we had like 3 or 4 of these things here nested down inside of each other, that would have a huge organization problem if we did not align these curly braces correctly. So that's where this is absolutely crucial and key, and it's very easy because that's what you're going to be looking for. Identify as, okay, where is this? Got it. Okay, and they're all vertically aligned like this, and this is the easiest formatting to keep track of that. So cool. I hope that helps. I'm going to continue on in another video and show you a few examples of if statements in use. Also, to look at Blackboard, there's a lot of examples that are there. And I'm going to show you a video on nested statements next, just so that we can kind of really get this concept. Everything else, take a look at Blackboard, take a look at the usage examples, and if you have any questions on that, feel free to post on the discussion board, and we'll go ahead and address the questions one by one. Thanks, guys.